Yeah, we have one. Okay, I'll take it.
We're running the slide. Okay. Hello. Okay. Hello, everyone. Well, welcome to INTAREA. Pretty light today. Yes. So, thanks all for coming. This is INTAREA at IETF104. The node well, as you must know by heart by this time of the week. So keep in mind that everything you say is under IETF rules, and we have to comply to the IETF policies and procedures. So as a reminder, minutes are taken. The meeting is being recorded. Your presence will be logged, and the scribe. Please help the scribe to contribute the minutes. You have the link to the Etherpad. So Ron Bonica, thank you very much for taking the minutes, but he's also going to be presenting. So if you can we have some other volunteer to complete whatever is needed? Someone else? Just for, the 10 minutes when Ron is going to present. Oh, thank you very much. And if you can log your name on the Etherpad, it'll be appreciated. Thank you. So blue sheets are going around. Note takers decided. And Michael, can you help us with the jobber?
I've already volunteered.
Thank you very much. I knew it. So for the jobber, actually, we have Dave Taylor that has asked specifically to get his presentation at the end because he has a conflict on the agenda. So he asked us to get a clue on the jobber so that he can run from there to here. So if you can just say Gu is starting, I think is the one before him, and then he will just give him a heads up. He will show up. Thank you. So the agenda, we'll give you the quick update from the chair slides. Then we'll have the provisioning domains, Tommy Pauly presenting this time. The SOX protocol from Vlad. Then the probing interfaces, Ron is going to give that. Generic multi-axis, convergence encapsulation, Jing. Tom will give them the GUI. Again, it was moved to the end from request, and this one was from David Black, because he also has a conflict. And at the very end, we'll have Dave Taylor. So a slightly different order compared to previous sessions, but mainly to accommodate people's and see Vlad is arriving, so perfect. So any comments bashing on the agenda?
So when was I supposed to ask?
On presentation 6.
So the last Dave is lost. Yeah.
Dave is last, so yes, if we can give him a heads up when Gu starts. Maybe calling his name out or something. All right. So we have some updates. The fragmentation considered fragile has been submitted to IESG for publication as VCP. The other two documents that we have are generic UDP encapsulation in INTAREA. So we'll hear the presentation. and the discovering provisioning domains also is on the agenda for presentation. We have one more announcement.
Yeah, just a quick note, draft Carpenter limited domain has been updated, and Brian asked for to post feedback on the mailing list, please. He couldn't attend this time.
Yes, please, thank you. So the first one is Tommy Pauly. Thanks. And we go.
Hello.
This one. This is the clip. That's Tommy.
All right. Hello, everyone. I'm Tommy Pauly, and I'm presenting our updates on the provisioning domain drafts on behalf of my co-authors, Eric and Pierre, and David and Wenking. So first, just make sure everyone's been paying attention, keeping updated. I'm going to give a quick overview of how the protocol is working, and then talk about the things that we've updated, the things that we're going to plan to update, and the rest of the status there. So what we're defining in this document is a new RA option for explicit PVDs. PVDs are provisioning domains that were defined in the multiple interfaces architecture. The RA option provides a PVD identifier, which is a FQDN type name. It encapsulates other RA options that are specific to that named PVD. And it may or may not be tied to the other information that's advertised on that network via DHCP. And then separately, this document also defines a way of fetching additional information about this provisioning domain. This is available in JSON, and it's retrieved from an HTTPS URI. And amongst other things, it gives you the v6 prefixes that are provided by that PVD, and that can help you detect some misconfigurations on the network or help validate the configuration you do have. Just to look at the format, here is the current format from the document of the PVD option itself. We have a sequence number to detect when changes are made. We have the PVD ID itself, and then it contains other RA options within that. We've gone over this before, but just here's a different way of visualizing kind of the relationship of different PVDs that could exist on the network. This is a complicated example to be exhaustive in all the different combinations and how things can relate from a client's perspective. So in the first case, let's say we have some RAs coming from source address A. I could have multiple explicit PVDs coming all from the same source address that are named differently. These can be related to DHCP if there's a legacy flag in the RA option marked. So we could tell that these DHCP options belong to all the information that comes along in this explicit PVD, and that can be further related to any of the additional information we provide. I could also have another source address that's giving me both DHCP v6 as well as RAs, and those could also be linked. And then I could also have any other source address that I get information from can be implicitly treated by the client host as a PVD, even if it's not named. So these are kind of like the ecosystem, the zoo of all the different ways the client can detect these different provisioning domains. And each of these groups on the right are domains in which we would have separate DNS caches and ways of using source addressing. Here's an overview of what we have in the mandatory part of the JSON registry. We have a name, we have when this configuration expires, and the list of prefixes mentioned before. We also have the ability to extend this, and we list a couple of the optional attributes that can be added to this JSON registry. So that's the overview. As far as what we have updated since the last IETF, we added a section discussing the use of DNS within PVDs. A lot of this is already kind of implied by the PVD architecture, but we wanted to make it really clear when you're using explicit PVDs. DNS configurations that you have must be used in an isolated way per PVD. This helps you manage the split DNS scenarios that you may have. One other thing that we call out is that this is not meaningfully improving the trust of your DNS provisioning. Although, there's been discussion, and it's been brought up here before, that as we have more encrypted DNS mechanisms like DNS over TLS or DOE, there's a desire to have some sort of authentication about the validity of these configs. Potentially, you could see this as a benefit if you have a PVD that advertises a name, and then as we are fetching the information, we can validate the certificate and at least the authenticity of this name that's being provided. It's currently not done in this spec, but if some of those DNS mechanisms like DOE wanted to use PVDs to provision those DNS servers, they could potentially extend the attributes in the JSON format to also have ways of saying, yes, and this indeed is my secure DNS server, and have at least some way of validating or signing this information. So it's a tool, but this document itself does not provide the end solution for that. It's a stepping stone along the way. There's also some asks for clarification and improvement of the rigor of our language in the IANA requests. So we clarified the request for registries. So the two names of registries we're asking for are additional information PVD keys. This one is proposed to use expert review to add entries. And then there's the PVD options flags, which is the options within the RA, the flags within the RA option itself. And that we're saying will require standards action. We don't expect that would need to be updated very often, and that's much more important to kind of have locked down. So that's about it on updates. Eric actually gave some thoughts to the list about how we can improve some of the uses of our suggested headers and stuff. So if you want to summarize those, that'd be great at the mic. I think we will plan on incorporating those. Other than that, we have done interop with this. We've used it for captive portal stuff, and that's gone well. We believe the document's pretty stable. We'll incorporate this, so we'll definitely want another rev. But once we do that, I believe the authors are all looking for a working group last call on this and to get a nice, serious round of review. So thank you. Please share your thoughts.
Eric Klein, let me just do as you asked. I think I said for the inner RA header, why not just leave it alone? Type, the code already has to be 0. Type could still say 134. We could say the checksum has to be 0, but we could also say everybody has to ignore it. Okay. And then I also said I kind of liked what Billy did with the universal RA option, having JSON and CBOR options and reserving IETF sort of namespace. And then also mentioning and or recommending x-foo is contrary to RFC 6648.
Right.
Which says thou shalt not.
Yes. So we just want to get rid of that recommendation. Just scratch that entirely.
Yeah, I don't know, although what we would want to do for, well, so that's actually where the IETF prefix of things
yes.
would mean other people could do other things. I don't know how that actually works with 6648.
Yeah, so we'll do our homework on that. But essentially saying rather than having the reserved namespace be the one with no prefix and make people do x- for extensions, take the IETF prefix for the document ones and let people do whatever they want otherwise. And that's, I think,
it's a thought.
It's a good way to go. We appreciate that.
I don't know if it's good or not, but it's a thought.
Michael Abramson. So, well, I think this work is important. I think it's needed. I'm a bit scared about if we have understood all the ramifications and like how to do this and so on. You were talking about you had done experimentation in captive portals.
Yes.
Is there? So if I read the captive portal, will I find some description about what you have done, what actual code you've tested?
We have a draft. It's not in the core architecture drafts, but it's referenced by them. And so currently it's an individual draft. It's slightly blocked on this, actually having that be a real thing, but it does describe how we use PVD discovery to bootstrap captive portal discovery. And that's essentially what we did in our hackathon work.
Okay. Oh, so it was a hackathon project.
Yes,
so I could
there-
also
there
go
were-
and look
yes,
at it. Okay.
correct.
Was it this hackathon? Or
No, it was not this one. It was a previous one.
Okay, thanks.
Yeah, two ago. Yeah. All right. So any other thoughts? I don't know. Can we get people to commit to a review?
Yes.
Eric, thank you.
So we have
But we'll make some updates if you could check the new one. Anyone else? How many people have read some version? Okay. How many people have read the recent version? All right. So we'll do a rev based on Eric's comments, repost, and then we'll ask for review. What do we think about last call status after that? What's your impression, Jaros?
Well, so far indeed, the document is rather stable, and we have Suresh getting to the queue. We had asked the security directorate for comments, and we haven't heard from them. So that could be something
Okay.
useful to
So we can
get
ping them
the
again?
feedback before we go to other stuff. And then we have Suresh on the queue. Oh, Suresh. So, one.
Hey, Tommy. Hey, thanks, Juan Carlos. That's like pretty much what I want to talk about too. So I sent like multiple reminders to the SecDir people. The chairs had requested a review, and I talked to Eker as well. So like Eker is like rolling off the IESG this week. So I'll talk a little bit to Roman as well to make sure that this gets done pretty soon, because yeah, it's been like I would think like it's order of months, like 6 months or 7 months we are waiting for a review, if I remember correctly. Okay, so I'll just make sure this happens quickly.
All right. Thank you so much.
Thanks, Suresh.
Thanks.
Great. All right. I think we're done.
Okay. Thank you very much. So next.
All right, so I'm Vlad, and I'm going to give you an update on our latest work on SOX v6. So in the latest draft, we've introduced the concept of SOX sessions. Now, this is exactly what you would expect. You gather a number of requests under the umbrella of a session, and you expect there to be shared state at the proxy as well as at the client. Now, shared state has been done since revision 1 of the draft, but it was done on a per username basis. But multiple use cases have turned up, and this seemed like an elegant thing to go forward with. So the first use case is Tor. Now, as you can see on this slide, I'm visiting Wikipedia. I'm looking at the web pages for dogs and cats. Now, for various reasons, Tor gives you a single circuit per bar domain. So and the way they do it is the way that the Tor browser does this is that it encodes the bar domain in the username field. So it basically makes non-standard use of the username and password authentication. And there's also an option to change the circuit used for a particular site. The way that that is done is that the browser starts using a different password, and the Tor daemon gets the hint and starts using a different circuit. Now, sessions are a very elegant way to handle this. The next use case is shared credentials. So let's say someone has a couple of 2 different browsers running on their machine. Now, if the 2 browsers are using the same credentials, they're going to have the same view of the token window. So here we've got X and Y. X and Y think that the window is tokens 1 through 100. And X starts by spending token 1. After some time passes, Y has no idea about what X has done. So it tries to spend token 1. Of course, the token is out of the window, and it basically wastes 1 RTT before it can reattempt the request. So at best, we're going to see occasional wasted RTTs on one client or another. At worst, one client can live lock another one. So here X and Y have similar aggressive workloads. However, X got a head start, and it got to spend its tokens ahead of Y. So here Y's only chance of being able to successfully spend a token and have a request honored is to be more aggressive than X. Of course, if we're when talking about bind backlogs, the clients using the same credentials can basically accept connections from that some other client was listening for. And authenticated clients cannot make use of any features that make use of shared state. So we've decided to move the shared, all features making use of shared state from we've decided to do it on a per session basis rather than on a per username basis. Now the mechanism is rather simple. So the client asks the proxy to create sessions or to tear down sessions, and the sessions can also be torn down by the proxy whenever it feels like it, either due to a timeout or for whatever other reason. Now, all of these options are part of requests and authentication replies, so the RTT between the proxy and the remote server plays no part in their timeliness. So SOX sessions are rather straightforward. So aside from the kind and length fields that all options have, we have a type field, which signifies what kind of session option we're dealing with, as well as an option data field. Now, what these types are is going to be crystal clear after I go through the next few slides. And the option data is only used for conveying the session ID. So establishing a session is rather simple. So the client places a session request inside its own SOX request. And it goes through the authentication process if needed. And then the proxy replies with a session ID. The session ID is an opaque sequence of bytes, and the proxy is free to place anything in it. So it can be just an integer. It could place some information and encrypt it and sign it. Anything goes. Now, this first request is also part of the session that it initiated. So the client is free to make use of whatever functionality that requires a session. So it can request a token window, it can request a listen backlog, or whatever else. Now, a subtle implication of this is that you cannot initiate the session from within a session, since the session request, since the request making the session request is also part of the session it initiated. All further requests carry the session ID. This completely bypasses authentication, and the proxy replies with a session OK option. Now, if the proxy doesn't like the session ID, authentication automatically fails, even if the proxy didn't require authentication in the first place, and the proxy signals that by including a session invalid option. Session teardown is also easy, so the client places the session teardown option and basically amicably tells the server that the session is no longer needed and it can delete all associated state. The proxy, of course, should keep some kind of timeout timer in case the client isn't friendly or if the client crashes or whatever. Now, we also have untrusted sessions. So the session ID can easily be sniffed by a passive attacker, and thus the attacker can just hijack the session and bypass any authentication mechanism that are in place. When a session is untrusted, the client must authenticate every time it makes a request that's part of that session with the very same credentials that it's used to initiate the session. Now, this is a bit of an open question. Do we actually need this feature? Because my general policy has been that whatever can be done by running SOX over TLS, I'm not going to handle in SOX. So I'd like your comments on that. I kind of lean toward removing this feature. Aside from NITs and other quality of life changes for implementers that we've made in draft 06, we've also done some future proofing. So now options have a 2-byte length field, so you can place whatever you want inside of them. They are still limited by the maximum number, by the maximum options length, so you cannot have more than 16K of options inside the message. But otherwise, options have no, individual options have no limit on their length. So you can place certificates, JSON dumps of the proxy configuration, or whatever. So if you, this was done so that whatever other options the IETF decides to standardize in the following years, they should be able to. The semantics behind authentication methods have also changed. So SOX 5 stipulates that authentication methods can also negotiate some kind of encryption and that the data is encrypted. Now, in order to keep backward compatibility, we still allow them to negotiate encryption, but it is no longer honored by SOX itself. So if you want encryption, run SOX over TLS or over some other encrypted tunnel. And that's about it for me. Thank you.
Thank you very much. Any comments for Vlad? Okay. Thanks a lot.
Thank you.
Okay, Ron Bonica, Juniper Networks. This is a very short, sweet presentation. Probing IP interfaces by virtual function interface. Next slide.
Oh, here.
Okay. This is an extension to Probe, RFC 8335. And Probe is a utility. It's used for probing the status of basically unnumbered interfaces. It's for pinging an unnumbered interface. What you do is send an ICMP extended echo message to a proxy interface. And in that message, you identify another interface, the probed interface, the one that you're really asking about. And the proxy interface gets the message, looks for the status of the probed interface. It's generally co-resident on the same device, and answers and says, yeah, the interface that you're asking about is up, down, whatever. Well, in any event, we've had some success with it. We have an internal implementation inside Juniper of RFC 8335. And we have a guy, sooner or later that'll become part of our product. We have a guy working on checking it into FreeBSD, checking it into Linux. But in any event, as we were doing this, somebody had a request. Right now, we can identify the probed interface by address, by interface name, or by IF index. The request was, well, I'd like to identify the probed interface by virtual function identifier. And Jen says, well, what's that? Well, in some PCI environments, that's a way to identify an interface. It's kind of like a IF index, just in a different environment. So, very short, sweet draft. We have a registry of all the ways that you can identify the probed interface. We need to add another entry to the registry. And that's it. We just need, I could have read the draft to you while standing on one foot. So, not much to see here. The draft is only one 5-pager. Please issue a call for adoption and maybe we can get it through quickly.
Okay.
Has anybody read it?
Do you want to read it now?
So Eric Ving, just as an individual contributor here, nice to see this RFC 8335 implementation because it helps so much if you're using link local only addresses.
Yeah. Oh, and by the way, more is coming in praise of link local addresses. We believe the only reason people aren't using unnumbered interfaces or link local only is because you can't ping them. This allows you to ping them. So
Michael Abrams, you should not make those statements if you want to keep it short. So I know people who are all kinds of worried about source address selection of the devices when they're making outgoing connections to whatever and so on. So there's a lot more than pinging them. But yeah, this of course helps. But how do you determine an interface is up? Like, is it just the IF status of the link?
Exactly, IF status.
Okay, so
Yeah.
you have no idea if you can talk to anything or if there is anything there. It's just that the driver says that the interface is up.
That's all ping does.
Uh,
When you ping an interface, there's no guarantee the ping came in that interface, and there's no guarantee the response came back out the interface.
Okay.
All you're doing is querying the driver.
If the device is not going out that interface, yeah, sure.
Yeah, yeah. Okay, so ask for reviewers, ask for a call for adoption, ask for...
Yeah. So, any volunteers to review the document, provide comments? Okay. Fred. Eric, thank you. Thank you very much. So we have Jing on the queue.
Hello, can you hear me?
Yes, loud and clear.
All right, great. Yeah, so this is Jing. I'm happy here to present the introduce the draft on the generic multi-access convergence encapsulation protocols, and this is in collaboration with Satish from Nokia.
Sorry, would you mind getting a little further away from the mic? It's getting too loud and saturated.
Oh, okay. How about now? Is it better?
Yeah, it's much better. Thanks.
Okay, yeah. Next slide. Yeah. So first talk about the motivation for this draft. So previously we have been working together on this multi-access management services. I think the draft is almost finished and is right now going through this informational track. In that draft, basically, we are introducing this new framework where we can support management across multiple access. For example, you can do path selection, path aggregation, splitting, switching. And for that, we need some kind of protocols to manage this process on the data plane. In that framework, we introduce three options. And the first option is the layer 4 approach using multipath TCP. And later on, we also add the multipath quick. And on the layer 3, we have two options. One is the IP over IP tunneling with GRE, which I believe there is some RFC that's already covered that kind of approach. And we also introduce a new approach, which is a light version of a layer 3 encapsulation using a trailer-based encapsulation method. And so this draft is mainly to address this particular option because we believe that MAMS itself is a fairly big topic. However, this encapsulation method is standalone. I mean, itself can be a reduced scope. I think one of the feedback we got in the last presentation in the IETF is that the MAMS itself is quite a complex topic. It will take some time to actually moving forward. So and then there's adaptation layer. So the adaptation layer is just to send this convergence PDU over individual radio access network, and then you can use different tunneling approach, UDP tunneling, IPSec, and client net address translation and pass-through. So those are just existing methods that without requiring any additional protocols. Okay, next slide. And in parallel, there is efforts happening in 3GPP architecture group SA2, trying to define a solution to support access traffic steering, switching, and splitting, switching, and steering, which is somehow aligned with our vision for the MAMS. And this picture just showed the, one of the option to support a layer 3 aggregation using the trailer-based convergence method. However, at that time, because the draft is still being defined in IETF at the early stage, so this part of work also being considered in the technical report 23793. If people are interested, definitely welcome to take a look. But this part of solution has been kind of paused or hold, waiting for the IETF discussions. So in other words, there is also a need to define a layer 3 protocols to support multi-access or multi-pass aggregation or splitting. So next slide. So this is kind of a conclusions that I got from the actually it's TR, not TS. Basically, in the TR, there's two type of solutions. One is layer 4, which is multi-pass TCP at that time. And then there is also ATS as a function that is sit at the layer 3 or layer 2.5, right below the IP. And at that time, the discussion is that it needs the IETF to complete the draft and publish the protocols. Then the SwitchGP can actually refer to this this work. So that is actually motivate us to bring this to this particular part, which is the generic multi-access convergence encapsulation protocol as a standalone draft, and call for kind of interest and hope we can get it adopted in working group documents. So yeah, so that's kind of the other part, which is in 3GPP, we also feel there is a need to define a new protocol to support this multi-access management. Yeah, next slide. Next one. Yeah. So so in summary, the problem that we try to address is that we are seeing that this multi-access convergence operation at the layer 3 is becoming very important. Previously, this kind of operation is mainly support at the layer 4, for example, multi-pass TCP, multi-pass QUIC, but those of solutions typically have a dependency on the OS, on the applications. By supporting this kind of functions at the layer 3, it allows us to support all the legacy traffic like TCP, UDP traffic. And currently, the only way to address this need is to use so-called IP over IP tunneling by including this GRE header and then encode all the additional information in the GRE header, like for example, sequence number. So in this case, the drawback is that first of all, there is IP over IP tunneling overheads. And also, it is very difficult to introduce a new field because pretty much we kind of hack GRE header, reuse it for other purpose. So it's very difficult to introduce new field. And then, yeah, next slide. A question?
So, yeah, we have a couple of questions. So,
Suresh said, "Don't do that."
Okay.
Instead, Suresh wrote to me instead. Said so. I'm quoting Suresh from the Java room. The mentioned 3DPP document is not a TS, as he mentioned. It's only a study item.
Yes, exactly. Yeah. That's what I want to clarify. It's a typo. Yeah. All right.
Okay.
Yes, next slide. Yeah, so I think the TS, the so-called stage 3 work is actually, they have this conclusion where if this draft being finalized, some solution we can develop in IETF is finalized before that the stage 3 work, or so-called the TS work is finished, then this solution can still be considered, right?
Okay, so one more comment from Suresh here. He says that it's not accurate to say that 3GPP work is blocked on IETF work.
No, I'm not saying blocked. Yes, I'm not saying blocked. I'm just saying that this particular solution, that the only way to consider it in 3GPP is that because in 3GPP we don't define any IP protocols, rather than reference to IETF work. So in order to moving forward with this particular solution in 3GPP, we will need IETF to work on this. Yeah, that's really what I mean. Yeah. So just to thanks for clarification. Yeah. So yeah, so talk about this particular encapsulation. Basically, what we are proposing is that have a new encapsulation format using a trailer-based encapsulation. And this way, we could add all the information at the end to avoid any IP over IP tunneling. And we also have the flags to customize what information we can include in the trailer. This is very similar to the IPSec ESP encapsulation, where some information also at the end in the transport mode. All right, so next slide. This is just show some example how we deal with single packet encapsulation. Also, we can do multi-packet or concatenation to improve the efficiency. And in the case when the fragmentation is needed, especially when the multiple access has different MTU size, we can also perform fragmentation at the convergence layer. And this is just show how that can be done with this trailer-based encapsulation. Yeah. Next one. So in summary, what we have seen is that to support the so-called multi-access convergence, currently in IETF, MAMS or 3GPP ATSSS has been developing solutions. Currently, in order to support aggregation, we only have two approach. One is at the layer 4. We can support either multipass TCP or multipass QUIC. At the layer 3, it's basically reusing the GRE header and using IP over IP tunneling. So in this case, we are focusing on layer 3 solutions. Instead of reusing the GRE header, we are proposing a new convergence protocol or encapsulation protocol based on trailer-based encapsulation. And this will give us a flexibility to introduce or enhance the features, as well as avoiding any kind of IP over IP tunneling overhead. And hopefully, if we can get something done in the IETF, then we can bring this back to 3GPP to have a layer 3 aggregation solution also being considered in the TS phase. Yeah. So yeah, I think this is my last slides, I guess. Yeah. Thanks.
Thanks. So questions, comments? Tom?
Tom Herbert, have you looked at GU?
Yes. So you mean the UDP encapsulation?
Yes. As you said, you don't want to be forced in IP and IP encapsulation. GU can do other forms of encapsulation, so it doesn't force you into that model.
Yes. So I think in general, we want to avoid is not just IP over IP or any like layer 4 tunneling as well, like UDP tunneling, right? So this kind of encapsulations is try to avoid adding additional header at the beginning or at the beginning of the packets to avoid this kind of overhead. So my understanding is that UDP or generic UDP encapsulation is also doing something like that. Yeah.
So there's a reason though why we see a lot of encapsulations using UDP, and that's because it's compatibility with the network. If you introduce a new IP protocol, you have absolutely no compatibility on the network. Devices may or may not even pass it. So it wasn't that we really wanted to do this in UDP. It was more like UDP gives us the best framework and the most compatibility with the network at a cost of a whole 8 bytes. So it's a trade-off that we've made in a lot of cases. So from that point of view, I'm not exactly convinced that we need another transport protocol.
Okay, so I think probably I should clarify it. It's not really a transport protocol per se, because if you look at the framework in the both MAMS and the ATSSS, they do have their own transport. So in other words, you could still do IP over IP tunneling if it is required, depending on your network, right? So also you can do in UDP tunneling, like we have. If we can go back to the slides 2 or 3, I believe there is. Maybe can we go back to the slides 2?
And we have Suresh in the queue. Just to
Yeah, slides 2. Yes. So you can see the way that we do this is that we divide it into 2 layers. The convergence layer is really just responsible for aggregation and all those management purposes. So therefore encoding those additional information. And then at the individual transport, we do include the UDP tunneling options if it's needed. Sometimes you don't really need. We have been testing this over like legacy devices by introducing a new IP protocol type, or even just reusing the existing IP prototype. It won't affect most of the layer 2 kind of switches. And then we have the IPSec tunneling, or the other type of adaptation layer, like method. So I guess to clarify is that refer to your point of the transporting, the UDP tunneling is supported. Yeah.
Okay, so one other question. Why did you go with a trailer-based protocol? Everything else is headers. Is there a reason for that?
Sorry, what's the question? I didn't catch it.
So this is trailer-based GMA encapsulation. Why trailers? Those are very, very hard to process in a host.
Yeah, why the trailers? Yeah, so the reason we want to use the trailer is that if we introduce anything at the beginning, then we have to do a IP over IP tunneling, just like what we did with GRE, right?
But you don't. You said you were introducing a new IP protocol. So the IP protocol could just say, or a new protocol number, this just says, this is the format, you have this header before the payload. So if you're already introducing a new protocol number, then define a new header.
Sure. Yes, I think what you are referring to is that you can also introduce any information at the payload, at the beginning of the payload, right? Is that what you're saying?
Yes, just like it's a header, right? So you have header followed by payload. This is the common convention.
Yeah, but the things like this,
trailer, we have to hop around. It's really hard to process that from a protocol processing point of view. So unless there's a good reason, keep stuff in the front and headers.
No. Okay, so I think what you are saying is that if we want, we cannot add the beginning of the IP header, because otherwise we have to add another IP header to encapsulate this, right? So if the point is that we're going to add this information between the IP header and the payload, then it's actually violating the protocol stack, because the header that right after IP header is usually the layer 4 protocols, right? So if we go back to the last slide, if we go to the last slides, can we go to I think there are some backup slides which show, so in this case, so this is how we do this in the IPSec, right? So there is information being inserted at the beginning of the data as well as the end of the data. The whole point is we are looking at the transport mode, not the tunneling mode. And in this case, we keep the IP header at the same, and then we just introduce the new information there, right? So in our case, we really don't need so many information, so we just add all the information at the end. So this way, the layer 4 header is still right after the IP header. If we do something like ESP header at the beginning, then it will be hard for the host to process. If we want to do any deep packet inspection, then you have to add this offset, right? So that's something that we want to consider. But obviously, we can also consider, if there is really a need to insert at the beginning of the payload, we can also add that.
David Black, let's have a discussion about data paths, because the location of the ESP trailer and the location of other trailers has quite a bit to do with what the data path has to do. So on this diagram here, the crucial thing to observe is the authenticated double arrow, which is the second one under each of those. That authenticated indicates that the receiver is running over the data covered by that double arrow and is calculating a MAC, a cryptographic integrity check. If you think about how a data path has to work, you want to run data through the data path once. So you want the receiver to go running down the data path, calculate that check, and then the trailer shows up right when the check has been calculated. You compare them and figure out whether it worked. Now, what we have here sounds like a forwarding data path, where you'd like to know where you're going to send the packet as soon as you possibly can, as the packet shows up, and how you're going to deal with it, without having to wait for the whole packet to show up and discover in the trailer how you intend to deal with it. So for those who didn't follow every detail here, ESP is a bad design analogy unless you are doing some kind of integrity check or other pass over the data that is required to correctly process the trailer. CRCs in Ethernet trailers for the same reason.
Yeah, maybe let me reply to that comments. First of all, the purpose of this trailer is not for deciding which path to use. So there is a separate control logic to decide each packet where they need to go, regardless of how you do the trailer encapsulation. The main purpose of this trailer is to carry additional information that, for example, sequence number, when we split the traffic across multiple paths, then we can perform reordering operation. So when on the data path, what happens is that when you receive a data packet, like IP packet, we just add this information at the end, and then at the receiver, you get this sequence number from the trailer, and then you will perform reordering. And after reordering, you remove this trailer information, and then continue with just send this packet over to the rest of the network. Yeah.
Okay, so at the center, you've got quite a bit of flexibility of where to put what, because you're assembling the whole packet and everything else. At the receiver, the packet's moving onward. If that sequence number comes early, it becomes easy for an equipment designer to say, "Ooh, this is the expected sequence number. I can queue this thing up and pipeline the packet out and get it off my hands now," as opposed to with the design here, you're basically forcing a buffering stage.
I don't think you could actually get earlier. Even, I mean, the idea here is that you have to get the whole packet to do the reordering. You won't be able to process this packet, regardless. Like if you just get a partial of the packet, let's say you get first part of the packet.
We're in violent agreement. If the packet's out of order,
yeah,
you've lost one round of the game and you must buffer to reorder. However,
yeah,
if the packet is in the expected order, it is possible to dump it through a fairly shallow pipe and get it out of here now, as opposed to paying the store and forward buffer. There are hardware designs that do this in this space and others.
If it's in order, then regardless if it's in order or out or whatever, then you still need to recover the whole packets. Either remove the ESP header like here, or because you need to recover the whole packet before you can send it out. It's not like you can just, yeah.
I'm sorry. I know of hardware that does things you're claiming are impossible. I think we're going to agree to disagree.
Okay.
So Suresh had another question. Given that MAMS is not on the IETF stream and has moved to the independent stream, is there any IETF work that will use MAMS?
No, I think right now the only thing that we refer to is the MMS in IETF. But we do, as I mentioned, that we do have the reference in 3GPP documents, try to use this. So the plan is that if we can define something here, then we will be able to refer this as into 3GPP next release. Yeah.
Okay. So thank you very much. So we move now to the next presentation. So Tom. So can we give a heads up to Dave Taylor? Cheers. The other Dave Taylor.
Sorry.
No worries. Thanks. Thanks, David. Yes.
Thank you guys for your joking.
No worries. Thank you.
Okay, I'm Tom Herbert. I'm going to give an update on Goo. So we had some substantial reviews from Charlie Perkins, David Black, Gary Fairhurst. Thank you very much. They were very good reviews. I think we're getting a lot of good feedback. So most of this presentation will be responding to those reviews. So I'll split the comments into two major sections. I tried to extract the most operative comments. So these are the clarifications. And then next section, we'll talk about a few more in-depth. So Charlie mentioned that we needed an applicability statement. That is in version 7 now, so please take a look. One of the comments was, how do we prevent middle boxes from filtering based on GU options or GU data? And I think the short answer is we can't. In some sense, anything we send in plain text is susceptible to middle box intrusion and middle box detection. What we do, though, is we do say middle boxes should not look into the GU payload or GU header. We also say they must not modify any of the UDP payload. And we have the ability to authenticate the headers to prevent modification. And for the most secure setups, we could use DTLS over the whole GU payload or GU frame, so it wouldn't even be seen. David mentioned that we need a reference to draft in area tunnels, so we'll add that in the next version. Okay. We needed a normative reference to the GU extensions. So, you want to comment?
Sorry, the comment I made from the bleachers, as David Black, the draft into area tunnels isn't just a reference. You need a reference and some. You need a reference and some discussion based on the content of that draft.
Okay. Yes, I actually looked through it. Most of the things we covered already. I think, if you want, there's a few things that aren't applicable. We need a normative reference to GU extensions. So there's a base GU draft, which we're mostly talking about here. GU extensions, which is also in working group last call. So there's a mistake in the last version of the draft that did not provide the right reference. So Gori pointed that out. And there was also a comment that we are lumping tunnels and encapsulation together. So this may require just a bit of clarification. GU is an encapsulation protocol. And it encapsulates by IP protocol number. So any IP protocol can be encapsulated in GU. Tunnels really are when we're encapsulating a packet, IP, ether IP, that. So this was kind of specified in the document, and we do have a little bit of handling for both those cases. So that might just be a terminology clarification. I think Gori has a question.
Hi, Gori Fairhurst. A bit like David, maybe you need a little bit more text explanation about it, because I see the two aspects.
Yes.
And I see you talk about the two aspects, but I don't see a clear separation in your thinking when you describe the two aspects. And I have different things I would like to check off in the two different ways. So it's more than just kind of casting it aside and saying,
okay.
Yeah.
So, well, I think they need definitions, exactly what they are, and then we can do some elaboration. So there are 4 issues that I wanted to give a little more comment to. The zero UDP checksum and IPv6 congestion considerations. Congestion control is the wrong word. And then the question about it, GU being too flexible and extensible, and then why propose standard. So UDP v6 checksum, this is something that has to be handled by all UDP encapsulations. Per RFC 8200, UDP checksum is always required for IPv6. However, that was relaxed by RFC 6935, 6936 under certain conditions. So the rules in GU, and this might not have been clear, but there's three possibilities. One is use the UDP checksum for both IPv4 and IPv6. That's actually the recommended approach. There is something in GU called a GU checksum. This is in the GU extensions. It does include a pseudo header, so it is an acceptable replacement, I think, for the UDP checksum. If neither of those are used, then we have the fallback to we're using a zero UDP checksum without any checksum covering the IP addresses. That is where we would talk about 6936 being applicable. So I think your point, David, was basically that we didn't have enough description of the provisions for going to 6936. So my thought is, we already did this in RFC 8086 for GRE over UDP. Most of that should be applicable in this case. So I was thinking about cut and paste.
Yeah, that's good. I mean, yeah, yes, and you got it right. The thrust of the complaint was a show your work complaint. Some of it requires some design thinking. Although the GU checksum should be incredibly useful, because the GU checksum gives you an out from the conundrum that is causing zero checksum headaches elsewhere, which is either you turn on the UDP checksum and it costs you a pass over the entire data, or you turn it off and your traffic goes heaven only knows where. And the GU checksum is just a slightly larger header checksum.
There is one caveat, and that makes this interesting. So the UDP checksum works with NAT. The GU checksum doesn't really work with NAT because we don't want middle boxes modifying.
And we can have a bug versus feature discussion over some fine Czech beer.
Anyway. So we have congestion considerations. Unfortunately, this was misnamed in earlier versions of the draft as congestion control. GU does not have congestion control. We were trying to go for congestion considerations. This should be nearly identical to RFC 8086, where if the traffic is not congestion controlled, we have to have provisions within a TMCE, traffic management control environment. We should be able to apply the same rules in GRE over UDP. So again, I think that might be cut and paste from RFC 8086.
Should be, in addition, I forgot when I was up at the mic the previous times, David again, to give you and probably Gory something else to look at, because we're working through some set of these issues, I think particularly zero checksum with the Geneve draft in NV03. So you might also look there for some useful text. I just got finished working a review of that one.
So hopefully they're all UDP encapsulations should be kind of the same, right?
They should be similar. What's going to happen is that some of the requirements in 6936 are design time requirements. In essence, 6936 says put on your thinking cap and make absolutely positively sure you understand the potential consequences of packets going to the wrong place and have come up with the best you can do for this protocol to mitigate them. So it isn't quite copy paste, but there is similar design thinking involved.
Okay. Corey.
Gory +1. Think about whether you want it deployable only in a controlled environment. If you make big claims, or then write text to clearly explain why it's not just for a controlled environment.
So the rule is, I think, if you're using non-congestion controlled traffic in a controlled environment, here's the provisions to allow that. Do not use non-congestion controlled traffic outside on the internet or externally. If it is congestion controlled, then by all means use it. There is one difference here.
By the way, I'm not mean enough to try and get you to compose a sentence live in front of us. So I'm quite happy to talk with you afterwards, because, yeah, I accept there's different environments and you just need to be really clear in your applicability. Yeah.
So let's talk afterwards. I'm not.
Yeah.
There's a subtle subtleties here.
And 8086 also has the framework that you use to do TMC and non-TMC. And one of the things you can think about is whether to allow zero UDP checksum for IPv6 in the general case. It's possible to say that you do zero checksum only in a TMCE. But in general, you've got flexibility, and the 8086 has the framework with both environments, and it'll give you some idea of how to write the applicability statement to figure out what's going on.
Right. So I'm still thinking most of that can be transferred. We'll do a little bit of design.
I'm so glad I have the scars from getting 8086 done. They're actually valuable.
Okay, so moving on. There was a question about flexibility and extensibility. A little bit subjective, but I will point out that there's two parts, I guess, to being flexible or extensibility in Go. One is we have a concept of extensions and options. One is the protocol types that can be encapsulated. So in the first case, Go has this thing called flag fields, which are very much like GRE, the GRE mechanism. If we compare those to TLVs, they are very constrained. And the design philosophy behind this was that, yes, the protocol is extensible, but we do not anticipate hundreds or thousands of extensions or TLVs. So because it's in this format, a lot of the problems that you see with TLVs go away. So there's only one possible ordering for any given set of options. There's no concept here of ignoring unknown things. It's very efficient, amenable to TCAM. And as I mentioned, we expect kind of a slow growth of extensibility here. And that's also based on looking at other protocols like IP, TCP that had options and realizing that very few have actually been added and very, very few have been used. Nevertheless, we need the capability to be extensible. So the second part is the protocol field. Go is a little unique compared to many of the other encapsulations. We encapsulate by IP protocol number. So that includes IP, IPv6, and the normal things we think of in encapsulation. But that also does include transport protocols, for instance, TCP, UDP, SCTP. So that is on purpose. And the document does describe the processing of that to make it sane. The basic processing is that the UDP and the GU headers are effectively an extension header in terms of processing, such that when they're processed, they're removed, and the resultant is the IP packet followed by whatever is after the GU header. That is the resultant packet. And this is, I think this maintains logic or logical approach. We do have to consider, for instance, if we're encapsulating a TCP header, so you have UDP, GU, TCP, where does TCP get its IP header for the pseudo checksum? So that has to go all the way back to the initial header. And that also bleeds into the transport versus tunnel incap. So there's a little bit of difference, not necessarily the processing difference. This is all the same implementation-wise, but the what actually happens difference. There's also private data in GU, which we do not specify the contents. Anyone can put anything there. However, that has to be agreed by both endpoints. Network has no say in this, hopefully.
Mia Kulevind. So as you said, network has no say in this and has to be agreed. Why do you need it on this layer? The private data, sorry.
Private data, if we don't put it in, people will hack up the fields.
But there's an extension field. You can extend it, right?
Well, so imagine I'm a private entity and I want to try an experiment or do something different.
Yeah, do it. Like
So
you don't need to specify here.
If we don't give them something,
Extendable,
like-
an extension field, yes.
it's extensible, but the fields have to be standardized, right? So we can't, one thing I should mention, so we can't say this flag bit is extensible or can be used for private uses because we have to specify a size for everything. So all the flag bits are associated with a size. And so I can give you an example. So we tried to extend GRE before. And what ends up happening is people end up overloading sequence number and checksum field because they weren't used by hardware. And it's ugly, but what I saw was we were using those fields for something completely different than they were designed for. Problem is that's not interoperable. So if we ever ran something against another implementation and both were using these random bits for different purposes, then that's a problem. So it's like, in a sense, it's like having experimental protocol numbers. So we're just allocating this base.
So it sounds a little bit like you tried to design something in the blue where you not exactly know what the problem is and what it will be used for, and I don't think that's a good approach. And the other point is if you actually have a scenario where you have like two tunnel endpoints that want to talk to each other and exchange data, then you might also want to consider just having a separate control channel for that, right? So it might just like not be a functionality that you want on this layer at all.
Sure, there's a separate control channel. So one difference, we don't want to rely on the separate control channel. So I want to make it clear that if you receive something you don't understand, it can be dropped. There's another reason for this. It also allows us to extend the protocol. So for instance, that previous description had a very ornate format. So not everything is amenable to being a flag field. What if I just put that into the field itself? As long as my receivers understand what's in that private data, then that makes sense. Now I don't have to go and consume a flag field. These are a precious commodity on purpose. So we only have 16 bits. So we want to make sure that the only things that are actually standardized in these flag fields are things that are universally important. Anything else, we want to go into kind of specific use cases. We can talk offline.
Yeah, but I still have the feeling that you're like trying to solve a problem by adding some more space, and then you will run into the same problem later on again.
Okay, so we have Suresh on the line.
Yeah, so thanks. So one of the things I wanted to point out, Tom, is that, right, like one of the things that Gori brought up was there's like insufficient justification for a lot of these extensions. And because these extensions are present, like the protocol is like too vague and too loosely scoped for it to like be good enough for a proposed standard. So one of the questions, like that's actually two questions, right? So can you trim some of these things and just like put in like some place for extensions without doing all the extensions? That's one thing. And the second thing is like, why do you think you should not be an experimental protocol? So you go and play with this and come back. So those are my two questions for going forward.
Okay, I can answer the first one. So we did split the protocol specification into two parts. So GU itself does nothing more than define the mechanisms, the extensibility, header length, and is relatively simple and straightforward. Then the second part is there are the base extensions. For instance, checksum, we've already talked about. Fragmentation, that's justified, I think, from a lot of other discussions. So the purpose was to break those into two parts and make that a separate discussion. So the base encapsulation is this. It does not define any extensions whatsoever. The next document is intended to be kind of the initial set of extensions.
Gori?
Gori first. When I read it, I had to read the other documents. It was a bit confusing. I didn't realize that they were working group documents at the time, but I found there was references across. There were things that you had here which you said you needed, and they were in the other documents.
I'm not sure we said we need them as opposed to you can use them. So
okay, so we can remove them from the base and simplify it
without requiring any of those extensions. It can be deployed with UDP encapsulation and gives you those values. The extension, so security is an interesting example, right? So we do want to have security extensions. Those are not required for every use case. So those are in the other document. However, it's logical to say, since it's extensible, I will want to have security extensions, and that's how I will secure the protocol.
There's a lot of pages of text, and I didn't find it that easy to go through them. So,
well, I mean, so I think you can also compare this to other protocols. I mean,
Sure.
This is not going to be different than Geneva, which will basically do the same thing. There will be a base protocol. They're going to be defining a lot more TLVs because it's designed for a greater number of TLVs. So again, all this to me, the whole question is somewhat relative.
I think Suresh captured my comment. I'd like to know what the reason is we're doing this, so I can check off whether these are the right set of things that are in there. And I trust that the working groups looked at this and that they have that list, but you need to get it into the document. If you
Reason
have
for
that
doing what?
The different options, the format you've got, the extensibility of the format you've got. I mean, so there's a lot of features, there's a lot of pages, there's a lot of options. They are dependent on one another a little bit.
Okay, so to be clear, there's two drafts. So are you referring to the base draft that defines the mechanism, or the draft that defines the first, I believe, 10 extensions?
And security document as well, isn't there?
The securities and the extensions.
Okay, all right. Is there only two documents?
Two documents. So there were references to some other documents. Those have subsequently been removed to pare down. So right now, the current version of the draft.
Maybe you've changed it since I read it.
The current version of the draft. There are two drafts in working group last call. The GU references the extensions draft.
I'm always happy to read again.
Yes.
Fred Templin from Boeing. So I just wanted to respond to the question about why proposed standard. We're using GUE in 4 different very diverse environments right now. We're having it evaluated in a company called Frequentis in Vienna, Austria. We're running it in the Amazon Web Service Cloud. We're also running it on a test airplane facility in Everett, Washington, and I've got it running on my workstation right here. So it's being used.
Okay. Thanks, Fred.
Yeah, but Fred, like if you can stay back at the mic, that's
I hear the bag.
That still doesn't okay. So there's like a lot of experimental protocols that are implemented and running, right? So the question is like, what is the right level of extensibility required for this? That's really the experiment in my head, right? So like, do we need this much extensibility in the protocol? That's the part I think like Gori brought up, and that's kind of like my question too, right? Like, how much extensibility do you need? How many tunneling protocols do we need? How many extensions to tunneling protocols do we need, right? And that I think like reads to me like an experiment, right? Like, we are going to try this, and like, at the end we're going to come up with like the right amount of extensibility, not too rigid, not too flexible, right? That was my question. So I'm just going to leave it to the working group. I'm not going to interfere in this, but that's certainly a question that I've seen, like, kind of in the subtext of like what Gori said, what Dave said, what Miria said, and like when I read the document, right? Like I would say really the right level of extensibility is just a question in my head.
I understand, and to be fair, what I'm running in my test environment is the direct encapsulation of UDP over IP. So I don't get involved with the extensions, but we do have a need for GUE.
That's perfectly fine, and that's why I separated my comments to Tom towards the extensions document, really, right? And that's why I want to figure out like what needs to get done.
So Suresh, on that point, so we have the shepherd for the GU draft. It would be great if we had a shepherd for the extensions draft, because we haven't had this sort of review. So the fact that there's too many extensions in there really hasn't been brought up before.
Okay.
And I think if that's the argument, then why not just go and talk about that draft separately?
Okay.
Unless you're arguing the mechanism itself is the problem, which again I will fall back and say, compared to TLVs, this is much less, much more constrained and more controlled, and it's impossible to add an arbitrary number of TLVs to the protocol.
That makes sense, right? So Tom, the thing I wanted to say is like when we decided to take this up in Interia, right? So one of the things I talked to you about is like, is this going to lead to a larger body of work? Yes or no, right? And so Interia is really like a place for doing like small things that like don't have a lot of follow-up work to do, right? And for me, the extension stuff looks like a lot of follow-up work to do, right? And you may not agree. You may say it's like very bounded and everything, but like that's like the extension document is like serious extra stuff.
Well, right, but it has been in working group last call for a while.
I understand, right? Like, but the question is like if we decide like what we're gonna do with that, I think that then like it's easier for me to like decide what to do with this, right? Like I think like people are reading both the documents when somebody says go.
Okay, so I am concerned if we start going down that path that will reset the clock and this will be another long process. So my preference would be to avoid that. Okay. The GO draft stands on its own in one sense. It is, and if necessary, we could take out the references to the extensions and say this is the protocol, this is how you extend it. That is really, I think, the higher order bit, at least for me, is to get that through.
That makes sense, Tom, right? Because like I think the concern is like people need to read the extension document to make sense out of this like base document.
Okay, so your recommendation is to remove references to the second draft? Then?
Yeah, so this draft needs to stand alone, like for it to go alone.
Okay, that's reasonable.
Okay. Tommy, Polly. So yeah, again, looking at the core document, I think I agree that it'd be good to stand alone. And with regards to kind of the extensibility, I think the issue is not, for me at least, like the number of extensions, but it's the number of degrees of extensibility potentially in just the basic header. So I think particularly like when we look at the private data, that does seem a bit concerning. So like if we imagine if we just like left out the definition of private data right now, it wouldn't, I don't think it would actually change anything. So we already have, so we have flags for extension fields, which yes, you may not want to consume one, but you do have an option there. We have a version field, which we could always rev to change the meaning of that. And you could even have another document in the future that defines when you have the header link that goes beyond your extensions, what to do with them. And so like we don't actually need to specify and reserve a private data here.
Okay, so.
And we still have all the flexibility in the future to extend it how you want.
So you want to create another UDP surplus area? I mean, we can do that.
Well, I mean, that's essentially
So
what it is right now.
We have these extensions. They have a certain length, which we know. There's a header length which should be different. So you have this void space. If you want to make it undefined, that's fine.
Now, and it may be just simpler to say that until you have a definition and a specification for how this is used, do not use that space. And it's easy enough for someone to come up with an experimental draft later that says, I'm going to use this space as my private data for X, and here's how I negotiate it. But until we have that definition, it's probably simpler to just leave
the problem
that
is it's private
out.
data, and the definition is, so I have used this before because I don't want to go and start stealing bits that somebody else may be using.
But that could be a
has
separate,
been useful.
It feels like there's not really a defined mechanism for how to use this point of extensibility, and the document would be stronger, I think.
So if it gets past the point, then we can take out any reference to private data. I do want to leave the header length in.
Yeah, sure.
And just not comment on it.
Mia Kulevin. So I do agree very much with Suresh and Tommy as well. And basically I just came to the mic to say, like, because Suresh said the right amount of extendability, and that was like Tommy clarified, this is like you have so many different ways to extend it, right? And it's not clear why you have so many different ways and what the use case behind it is. And like from protocol design, we know that this is like where the nitty-gritty bits are, right? Like this is where it gets complicated, and this is where we have all the problems. So you need extendability, yes, for sure. Like designing a protocol without extendability is not the right way forward. But like right now, it's just like kind of random here. And you could even go like you could even take the extendability space out and just use the version number to extend it further.
But what is random? That's random in the mechanism or random?
No, random or without having a use case, because if you don't know what the use case is, then it's hard to design it correctly.
So we don't know what the use case is for experimental TLVs, right? This can be used for anything. And people have used those for things that really weren't experimental. They were used in production.
The use case for expanded TLVs is usually to test your TLV and then come back and standardize the right one, right? And the use case for general TLVs is usually you already have like a couple of them in your protocol because you know you need them. But right here, I don't see any of that. And like, especially as it is an encapsulation protocol, you want to be careful about the number of bytes you want to use here.
So the point of extensibility is to cover the use cases in the future we don't know about, right?
No, you need some way to extend it, right? One at least. And that has to be flexible enough to cover these use cases. And then you can figure out how to use the space that you have in the right way when you have a use case.
Okay, so you're referring to the private data again.
Also, like, as
so
I said, you could break it down at this point, because also when I hear that they only use the base protocol without any extensions, at this point you could even turn it down to just have a version number and use
so
that.
that's one use case. We do have other cases. There's something called remote checksum offload, which is in production.
What's it need?
Microphone.
So Gori, yeah, what does it need? The other one, the other use case. Just so I get a picture.
I believe maybe Google's using it, as far as I know. So I haven't tracked all the use cases.
No,
I know this.
fine.
It's in Linux, so people can use that if they wish.
Okay, I would say the same as the other people who come to the mic so far. You can always publish a new RFC. I know Suresh wouldn't like you to bring a new RFC here, but you probably could in a short time if there are other people need other things. So not saying anything about your Slack area or missing some of the extensions out, yeah, that's okay with me anyway.
Okay,
that might make it easier for me to review it.
Okay. Fred, we have.
Yeah, so
Fred.
so Gori, I didn't say no to another RFC. I just wanted like further justification. So like I'm still open if like Tom comes back in a year and tells me like, you know, this is why it's needed for. So specifically the remote checksum offload is again referring to GUI extensions, right? So it's kind of like really circular. So like if like there's like somebody says like, hey, I need this, like it's getting done in the Linux kernel and I need this, like, yeah, sure, let's talk about it at that point. And that's why I said, Tom, right? Like the extension is like a bit more contested than the base draft. And that's why I want to kind of have a clean separation between them.
Right, but obviously the lack of a standard doesn't preclude us from deploying this, using this, and building products based on that.
Correct.
So, and it's not clear to me that that's required to justify it becoming a standard either. So we do have the running code, as Fred pointed out.
Not the extensions.
Well, so I'll talk to Fred. We had an extension. He needs an extension anyway, I guarantee you.
So Fred, and then we cut the line.
Okay, I just wanted to say, as document shepherd of the base Q draft, do we have a way forward for this document to move forward? And can we in parallel look at the extensions draft in parallel?
Yes, I did mention it already to Tom, and Tom agreed, I guess, right? Like to make the GUI draft standalone, make it readable by itself without like jumping back to extensions at all. So, and the extension,
Okay, and then I'll also ask. Sorry, Shush. I'll also ask: is it okay for me to be document shepherd of the extensions draft also?
It's up to the chairs, but I don't see why not.
Okay. I'll talk to you offline about that.
Okay.
Thank you.
Thank you very much.
Thank you.
Yeah, thanks, Tom. Okay. So let's have another discussion, continue on the email, and I'll send in my AD eval too. Like I kind of wanted to wait till this discussion before I sent it in, because I have shared issues with Dave and Gori. So if you publish a new rev, I'll send in my AD eval right after.
Okay. So next is Dave. Yes. Sorry on that. Here.
Mike?
Over there and there.
Okay, so this is about IF types, and so in case you're new, I have a slide. Next slide. There it is. Okay, if you're new to IF types, ancient history, way back when MIB2 was first defined, it included this notion of an interface table, so you can enumerate your interfaces, and each interface has a type. That registry is an IANA registry of IF type values. It was most recently defined, meaning across different updates and so on, in 2863 and 2000. That means the last time that this was updated, technically, well, it's not quite true, I'll get to that in a minute, was 2000. That means the time that the guidance for registering stuff was written was way before there was such a thing as IANA consideration sections. Okay. This does use an expert review, And the experts are Dan and me, and we wrote this document saying, here's what's happened over the last 18 years that are issues that we've had to deal with. Okay. This was done in the IFMIB working group, part of the internet area. The IFMIB working group closed long ago, so welcome to the internet area. By the way, just to make your life slightly easier, Suresh had said he's willing to AD sponsor this document if we want to do it that way. So, okay.
That's appreciated.
However, we do want input from the interface MIB community, which is now the internet area, since there's no IFMIB working group anymore. One of the last things that the IFMIB working group did was it defined a tunnel MIB, which says there's a particular IF type 131 that says it's an IP tunnel, and it created a notion of a subtype or a tunnel type. And in there you can find things like UDP encapsulation, GRE encapsulation, but not GUI encapsulation, hint, hint. And it uses exactly the same process and experts as the IF type. And so again, that's Dan and me. Currently, FYI, there's 296 IF type values registered and 18 tunnel type values that are registered. The majority of those are not from the IETF, but the IETF has some of the entries in both of them. That means most of the requests that we get do not come through the IETF. They either come through vendors or they come through other standards bodies, you know, IEEE or ITUT, and so on and so forth. And so our attempt here is to say, we have some designated experts that we've been operating on current practice for a while, and our understanding of what the IFMIB working group originally wanted, 18 years ago, of which I was one of the people that was there, and that's why I got stuck with being the expert after Keith McClary was the designated expert before me. And Dan was Ops Area Director for a number of years before Ron, or Management Area Director. Okay. So that's the intro. To help you understand a couple of the examples that are in there, okay, there's 3 types of relationships that are kind of interesting. The first type of relationship is a subtype. So I mentioned there's a type for a tunnel, and an example of a subtype is GRE. You can see there's a tunnel type numbering space that when IF type is 131, then tunnel type equals 3 means it's a GRE tunnel. Okay. Another example is IF type 6. This is a layering stack, right? Because you can enumerate X goes over Y goes over Z, right? And so this is an example of a tunnel that goes over the top of Ethernet that goes over the top of Sonnet, right? This is actually a valid example. And so here's an example where Ethernet, and then at some point in time there was defined, you know, fast Ethernet and gigabit Ethernet with different numbers that came in as alternate values. Later on, those things were obsoleted and said you should just use 6, right? And shouldn't be defining alternate versions that are essentially the same. And so that's actually one of the discussions that, and that's actually in an RFC, right? The one that says these are deprecated and just use this. That's the Ethernet-like interfaces MIB, okay? Okay, and so these are all examples from the IETF. The point is the designated experts have to deal with similar issues outside of the IETF too. And we want justification, and so I'm coming here to write this document so that we can potentially claim IETF consensus rather than that designated expert said so. Because right now guidance is scattered around about 4 different places between the IANA websites and a bunch of RFCs that aren't as easy to find. Okay. A third type of relationship is a sub-layer. There's plenty of examples of things that ask for 2 different numbers or 2 different layers. Okay. This is often the case when you have some multiplexing relationship or dynamic relationship here. Okay. So this point is there's subtypes, there's potentially alternate values that says, oh, this isn't quite GRE, I want GUI, and so that's an alternate value because it's not quite the same thing. Or maybe it is depending on which example that we're looking at. Okay. And then there's sub-layers where people want multiple of them. And of course, in this whole stack, again, I only pulled IETF examples, right? I could have constructed ones where everything in here was some proprietary one from a vendor, that's fine, or from some other SDO. Okay, so over the last 18 years, we've run into 5 issues, and so the document covers those 5 issues. The first one is way back when this is first defined, there was MIBs, and there was MIBs. But nowadays, we have things like Yang modules and so forth, and so people said, well, do I need one of these numbers? What does this mean for Yang, right? And so the current practice is documented here. This is not a change from current practice. In fact, RFC 7224 took the type numbering space and created the MIB module for them to say, hey, look, guys, it's not just about MIBs, right? So this did it. But if you don't obviously find that RFC, then you end up with these questions that says, I don't have a MIB. Why do I need an IF type number? Or what does this mean for me? So in practice, IANA actually maintains the actual registry in the form of a MIB module and a Yang module. Okay. Now, many registries come in, some formal syntax like XML. I can go and grab the registry in XML. Here you can go and grab the registry in MIB or in Yang MIB, module format. So the draft clarifies current practice, which is IF type values are not tied to the having an existence of a MIB or a Yang module. You don't even need either of them. You can just ask for a type. Okay. This goes for tunnel types as well. You can say, hey, I have GUI, but I have not defined a MIB module or a Yang module. Can I have an IF or a tunnel type value? Yes. Can you have an IF type value? If you convince us that it's not a tunnel, yes. Okay. Hint, hint about tunnel type. Okay. Hopefully that hint is getting across so I didn't have to get across up at the mic. Okay. So examples of current uses of IF type values. Okay. They are the values of a number of MIB and Yang objects, like when you read the IF table. They are parts of unique identifiers, like if I want to identify the MIB for Ethernet or whatever, they will show up in the object identifier for that MIB or Yang module. They are unrelated to any data modeling language like MIB or Yang. They are values exposed by APIs. Right? There's operating system APIs. You can go and query, and it'll say, here's the numbers. And of course, there's various utilities that display it in graphical UI and command line interfaces and so on. So these show up all over the place. So this is now mentioned in the document just for reference. That says, yeah, it's not just about MIBs anymore, okay? Because the original registry only mentioned MIBs. Okay, so that one was pretty easy. This one is more complicated, and that's why I showed you the picture here. Because we get requests sometimes, especially when it comes in from vendors that says, I would like a particular value. And we as designated experts have to say, you're asking it right. Okay. Oh, we're asking for a sub-layer. Well, did you actually mean to ask for a tunnel type or vice versa? Or did you want an alternate value or did you want a sub-layer, right? And so this is actually something that is not well documented. It's documented by example and by some text in the original interfaces MIB. And so we kind of tried to pull these together. And here we're actually proposing, and on the next slide, new guidance that wasn't previously written down that we believe reflects the intent of the interfaces MIB working group. We want to see if there's IETF consensus on. So here, what's the problem? Okay, I mentioned the difference between sub-layers and subtypes, right? And so the first problem is we have an IF type, or you can say there's various IF types that come in, or IF type request that comes in, or mechanisms that people are defining that by themselves are not sufficient to ensure interoperability with another implementation of the same thing. Okay. One example I mentioned was IP tunnels. Okay. You can't interoperate with another IP tunnel unless you match the subtype, right? It's not like GRE is going to interoperate with Teredo or something like that. That doesn't make sense, right? Okay. So another example is you're defining a layer, and without having the same sublayer below it, okay, you can't interoperate unless you have the same sublayer below it. For you IPv6 people, this means, yes, if you're IPv6, it doesn't mean you can interoperate with another IPv6 node. You actually have to have a common link layer to go, right? Same kind of concept, right? Same thing happens at lower layers. So what happens is if we get a request that says it's not intended to be interoperable with itself, okay, then of course, then what should we do? Because the next thing that happens is another vendor comes in and says, we have our vendor instantiation of that thing. Okay, do we give them an alternate value? Do we give them a sublayer value, which comes out of the same registry, right? Or do we give them a tunnel type value? Okay, we have to have enough information here. What should we do? Okay, so partly we want to document what we think the future designated expert should do. And secondly, we want to document what a definer should do to help us with the next request that says, oh, I want to come in as a vendor and here's my instantiation. Okay, so this is the actual text out of there. I'm not going to read the whole thing. I'm going to point out the bolded parts. Okay, the bolded parts is kind of what I want to highlight and maybe get input on. Okay, because the goal of this is to eventually get an IETF consensus document that we can use as backup or at least as guidance to us as to what to do, us or the future designated experts who replace Dan and I at some point in the future. The first one is kind of a statement of our belief of what IF MIB working group intended, and maybe you quibble with the wording or whatever, but the intent of an interface type or subtype is that its definition should be sufficient to identify an interoperable protocol But in some cases, you have to have something that goes below it or a subclass or whatever to make it be interoperable. Okay, and so here's text about a IF type definition should discuss whether to use a sublayer model or a subtype model in order to specialize it. Okay, so if I'm defining something that is not by itself not interoperable and a vendor gets to plug something into it, okay, whoever defines it should be the person that's providing sufficient guidance to say whether the next person that comes along should be subclassing it or sublayering it. Okay, and so we as designated experts can then follow that guidance that says, look, this is what the scheme definition said. Because right now we have to try to figure it out ourselves, and when the document is very hard to read, we're scratching our heads for a while, and that just slows down the process, and nobody likes that, neither us nor the requester. Okay. And so in one of these, if you're doing if you're saying that a subtype is more appropriate, then you should define a registry like the tunnel MIB did. Okay. And so in either case, give us guidance when defining one of those things. So, yep, we'll absolutely grant things that for which are not interoperable with itself. Example, tunnel MIB, I'm the author of that. But we defined a subtype model. In other cases, they defined a sublayer model. Either of that is okay, but tell us what the intent is. Okay. That's our intent of this text. If you have guidance on the actual wording of this, let us know. This one was the easiest one. I mentioned that some registries are maintained and grabbable in XML format. This one's grabbable in MIB or YAG format. What's happened a couple of times is that in those changes, it went to invalid syntax, and there are tools that consume it programmatically, and of course, those tools broke. And so all this did, what is it says, add a step in the INA process to verify it with a syntax checker before publishing it. INA has since done so, but this wasn't documented in any place, and so this is a recent change in the INA process steps. And so in the process steps in the document, it's now documented. There we go. Number 4 is transmission values. I mentioned one of the places that things can get used is in the identifier of a data model or of an object in a data model. And that's where this transmission value registry comes in. Okay, it's like in the OID subtree. Okay, there's a transmission subnode, and then underneath transmission is a number. Okay, and so that number is the transmission value. And so today, the transmission value registry is a subset of IF types. Okay, with the same value, usually with the same value. And there's no guidance written down any place on whether an IF type allocation should also get a transmission value or not, if the requester didn't explicitly ask for one. So we have vendors and other SDOs that come in and says, I would like a IF type for my favorite encapsulation or my favorite layer 2 protocol that I just defined. And IANA has to decide whether or not to grant them a transmission value. So what do? They ask the designated experts. What do? We scratch our heads and say, we're just going to allocate one whether they like it or not. And here's why. Number 1, saves us effort. If they come back later, they don't have to come back later, right? Less work for us, less work for them. Number 2, the numbering space is not scarce, right? It's not like you have a fixed bit field, okay? Number 3, the fact that we don't have to decide, right? It's just a policy means, hey, we don't even have to talk about it, right? And number 4, there's actually no case on record where having done that in the past would have caused any problem, okay? And so each time right now, IANA asks us, should we allocate a transmission value? And we say, yes, immediate response. And so we'd like to document that, okay? And say that is the guidance for future designated experts. And in fact, here's why, okay? So there you go. If you ask for something and don't need it, we'll give you one anyway. Eat your veggies. Okay. And the last one is also easily fixable, which is all the documents in the registries say to submit a request via email. But if you go to IANA and you look at the list of registries, you'll find a nice little form for submitting a request for interface type. So people come in and ask us, which way should I do it? Do I use the email like this thing says, or do I need the web form that's over here? And in practice, they accept it either way, believe it or not. And so we figured we'll actually say that so that people stop asking us which one to use. Now, I will mention that when I reviewed these slides with IANA, oh, she's back there in the back, she let me know, this is Michelle, let me know that IANA is exploring how to do it in the future with maybe a new registry workflow system. There's nothing we can tell people to do right now, but just a heads up, that fact is not in the document right now, but that is something that we may or may not allude to in the document depending on how IANA wants us to word it. So, okay. It'd still be a form of some type, is what Michelle said for those remote. Okay. All right. That is it. Okay. Again, there is a document right now. The main thing we want guidance on or want feedback on is specifically this text. The document itself tries to make a obvious distinguishing fact between text we've pulled in from various other places in current practice versus proposed changes. Okay, it should be real obvious because stuff was in like all caps as a prefix for anything that's a proposed change that we believe doesn't yet have IETF consensus. It's just been kind of up to the designated experts to decide, and we like backing, and so we put that in all caps as a prefix. So anyway, this is the example. All right, questions?
Michael Abrahamson, so is there any reason we shouldn't take the expert advice on the expert review process here?
In my expert opinion, no.
Good. I didn't see anything here that seemed to be, either or we should do anything. So, well, you seem to have been doing a bang-up job for 20 years. Nobody's complained.
I will say that there is
a
a reason we have 2 designated experts on this one, because the guidance is a bit slim in some cases. And so we have 2 designated experts. And so for anything that is non-obvious, we always have both of us check it, and we give the answer back to Anna once we both agree. Michelle's back there nodding, right?
Yep. Okay. So for this seems I'll trust you as an expert, and go ahead.
David Black, this seems good. Motivated me to take a look at the MIB, and the IF MIB is comprehensive, nearly 300 entries, including Type 132 for coffee pot.
Yeah, that's because that one was an April 1st RFC.
Right. However, the tunnel subtypes is from the Twilight Zone, the latter date. So what I got to do is sort of ask what comes next question. After this is dealt with, and particularly given that I think the tunnels draft says that tunnel endpoints are interfaces, should there be some kind of campaign to go get all the tunnels we've defined in the past, I don't know how many years, into the tunnel subtype registry?
Do you have someone in particular? Because like Softwares went and registered MAP-E and MAP-T fairly recently. I mean, fairly recently, meaning when MAP-T and MAP-E went to RFC, they were registered at that point. Okay, and so what other ones are you thinking about?
Let's see. You mentioned that GUI doesn't have.
Because GUI's not an RFC. You can get, by the way, you can get early allocation. You do not have to be an RFC.
They should
you
be
can
getting
get that draft.
They should be getting early allocations. Geneva needs an early allocation. I'm pretty sure VXLAN is an RFC and doesn't have an allocation. I can think of there are surely a number more where they came from. We've been very creative with tunnels.
That sounds like a great job for Internet Area and or the directorate from the area directors. And the designated experts look forward to reviewing those requests. Our whole goal in doing this is to cut down on the time it takes us to respond, right? Which makes everybody happy.
Yeah. So the next step is I'm going to kick off a procedure for this to go through the AD sponsored stuff. So I'll pick a few working groups. I'm immediately thinking of the NVO3 is one of them, Software is another one, Interia 6-man, probably some ops working groups. I'll just ship off a note to them saying this draft is there and then start the process.
Okay. I think that's it then. I've used all examples from the IETF in here, but as you can imagine, there's actually more requests, I think, that we get from outside the IETF than we get from inside the IETF. It's maybe about 50-50. Yeah. Okay. Thanks.
Okay. So thanks a lot.
Yeah, it's Michelle Cotton with IANA. I just wanted to say thank you for doing this. This is like role model expert material for any of you that want to be an expert in the future. It's a thankless job being an expert, but we very much appreciate it. And so thank you for the extra work you put into doing this. We love it when procedures get cleared up and when things are crystal clear for future experts. So thank you. You should present more. You're very entertaining.
Yes. And just from the Interia point of view, I think that it's true that we pick up a lot of garbage, but we also like to give awareness to most of the Interia and other groups. So yes, you're welcome to keep coming to present. All right. So, whoops. Sorry. Yeah. Sorry about that. I think that's it, isn't it? Okay, so thank you very much, everyone, and enjoy the rest of your day.
¿Cómo se dice la caja de retales en inglés? Si hay una expresión equivalente. ¿Entiendes la expresión?
No.
Este bulking es la caja donde cuando coses ropa y tal y sobran trocitos, lo vas guardando por si acaso.
La caja de retal.
Caja de retales.
Pues así es.
So, it seems we can leave this
This is the last session of today, I think so. I don't know. Right.